Okay, today we'll start the linear programming problem, how to formulate the linear programming problem. That means problem formulation. Actually, there are two types of linear programming problem. One is maximization problem, other is minimization problem. So today we'll try to formulate these two types of problems. Okay, the first type, maximization problem. How to maximize the how to formulate the maximization problem. A manufacturer produces two types of toys. One is A toy, another, there are two types of toys. One is A, another is B. Actually, to produce these two types of toys, we have to perform two functions. One is molding, other is polishing. Then we get profit. Actually, for toy A, we get profit 3 taka, and for B, 4 taka. Total polishing hours, how many? 180 hours, and total molding hours, 80. And this is given in the question, okay, in a manufacturer production. Now, profit on a toy A is 3 taka, and a toy of type B is taka 4. In what way the manufacturer allocates is his production capacity for the two types of toys so that he may make the maximum profit per week. That means to we have to formulate a linear programming problem in which the producer will get maximum profit per week. Okay, how many toys we have to produce? Let us consider the number of toys of A will be X, okay, and Y be the number of toys of B type per week. So profit on type A will be what? 3 taka given, and the profit of X toys what will be? Thrice X. Similarly, profit on one toy of B will be taka 4, and profit of Y toys of type B will be how many? 4Y. So total profit what will be? Z equals to per week 3 thrice X for toy A and 4Y for what? Toy B. So the Z is known as the objective function which we have to maximize or minimize. On one toy of A type is molding requires. For type toy A, molding requires 4 hours, and polishing how many? 2 hours. So for type B, molding 3 hours and polishing 5 hours. Remember it. Okay. So one toy of A in molding 4 hours. So X toys will be 4X. Okay. One toy of B type molding requires how many? 3 hours, and Y toys of B molding requires Y hours. So total molding how many hours? 4X for A and thrice Y for B. So total hours for molding 4x plus 3y, but it cannot be exceed 80 hours because total 80 hours molding. Understand? So 4x plus 3y less equal to 80. This is known first constant. On the other hand, for the polishing, for the toy of A on polishing requires 2 hours. So X toys requires twice X hours. Remember it. One toy of B type polishing requires how many hours? 5 hours. This is given in table. And Y toys of the B polishing hours requires total 5 hours. So for polishing, total time requires how many? Twice X for A and 5Y for what? B toys. But polishing works for only 180 hours. That means total polishing how many hours? 180 hours. So these total hours cannot exceed 180 hours. Understand? So this is the second constraint. And since the number of toys will be produced can never be negative, so there X must be first, number of toys A must greater equal to 0, and number of toys B type B will be must be greater equal to 0. And this is also third constant, and it is also called non-negativity restriction. So this whole problem here, this is the objective function, this is the first constraints, and this is the second constraints, and this is the non-negativity restriction. We can arrange in such a way to maximize z equals to this, because this is the profit, so we must maximize the profit. And subject to the constraint, there are two constraints, okay, and this is the non-negativity restriction. And this whole make a linear programming problem, because it involves the objective functions also linear, there is no non-linear functions, and in both constraints also linear. So all our functions are linear. So it is called linear programming problem. If any one of objective function or constants or both are nonlinear equations, then it will be nonlinear programming problem. So this formation of mathematical expression is known as mathematical formulation for linear programming problem. Understand? This is the for maximization problem. So another, we can discuss another problem. A manufacturer of leather belts makes three types of belts: A belts, B belts, and C belts. Okay, to make three belts, to use three machines: M1, M2, and M3. Okay, M1, M2, and M3. Belt A requires 2 hours on machine A, M1, and 3 hours on machine M3, and belt B requires 3 hours on machine M1 and 2 hours on machine M2 and 2 hours on machine M3. Okay, belt B. Understand? That means belt A 2 hours requires in machine M1, 0 hours for M2, and 3 hours for M3. Okay, and for belt B, take 3 hours in machine M1, 2 hours in machine M2, and 2 hours for machine M3. Similarly, belt C requires 5 hours machine M2, 4 hours machine M3. That means M1 0. Okay, 0 hours. So this is the third rule. There are 8 hours of time per day available in machine M1, but M1 machine available only for how many hours? 8 hours. And M2 10 hours, and M3 how many hours? 15 hours. Okay, so the profit gained from the belt A taka 3 per unit. Okay, belt A give 3 taka profit, and belt B 5 taka, and belt C 4 taka. Understand? So now we have to formulate the linear programming problem to maximize the profit. Okay, so we after reading this question, we have formulated this table. Okay, now the decision variable, actually, belt A will be x number of belt A will be x1, number of belt will be x2, number of belt C will be x3. Understand? So profit on A will be 3 taka. So profit on x1 what will be? Thrice x1. And profit of B will be taka 5 given. Okay, so for x2 belt of B, profit will be what? 5x2. So profit of one belt C will be what? Taka 4. And for x3 belt of C, 4x3. So total profit what will be? Thrice x1, 5x2 plus 4x3. And this is called objective function. Remember it. Okay, now for belt A, for machine M1. Okay, for machine M1, we can form first constant for machine to M2, machine 2 M2 will get second constant, for machine M3 will get third constant. How many actually? Their time available in a machine M1, how many? Total 8 hours. Okay, so the time required for belt A in machine M1 2 hours. Understand? For belt B 3 hours, and belt C will be 0 hours. So the required time x2 will be the 3x2. One belt of A will be machine 2 hours, so x1 will be how many hours? 2x1. And one belt of B in machine M1 will be 3 hours, and x2 for B belt will be M1 equals to 3x2 hours per day. So total time twice x1 plus 3x2 cannot exceed 8 hours, because total 8 hours available in machine M1. Understand? Similarly, for second machine M2, the total hours available here 10 hours. So we must know the time required for one belt B machine M2 2 hours. Machine M2 type B, belt B 2 hours. So x2 belt for B machine M2 will be twice x2 hours day. So one belt C machine in machine M2 5 hours per day, and x3 belt of C in machine M2 5x3 hours per day. Okay, so total required hours for machine M2 will be twice x2 plus 5x3 less equal to 10, because the total time hours available how many hours? 10 hours in machine 2. So it cannot be exceed 10. Total hours cannot exceed 10. So for machine M3 similarly, total 15 hours available here. So one belt of a machine M3 3 hours, and X1 belt of a can may need it 3x1 hours in machine M3. Similarly, one belt of B in machine M3 given 2 hours per day. Okay, M3 2 hours. So the required X2 belt B a machine M3 will be available at 2x2 hours per day for machine for B belt. So the time required for one belt C machine M3 4 hours. Okay, 4 hours machine M3 for C belt. So for X3 belt of C, we have denoted X3 number of C belt. How many? X3. This is why X3 belt C on machine M3 equal to 4x3 hours per day. This is the less equal to 15. Now constants you must know. This the number of production of belts of A, B, C can never be negative. This is why x1 must be greater or equal to 0, x2 must be greater or equal to 0, x3. And this whole objective function, this is the objective function, this is the subject to the constant. There are three constants. Okay, this from what? Machine 1, this from what? Machine 2, and this from what? Machine 3. Okay, and this is the non-negativity restrictions. So this whole make what? Actually linear programming problem. So we have formulated a linear programming problem and maximization problem, of course. And in remember this, for maximization problem, the inequality sign will be less equal to at least. Okay, remember it.
Okay,
For
sir.
maximization, less equal to. Now try to understand the diet problem. This is the actually we have to minimize the food. We have to maximize the food and minimize the cost. Okay, type 2 diet problem. Okay, there is a diet problem. We can formulate the diet problem in a LPP form. A dietitian mixes together two kinds of food, say X and Y, in such a way that the mixer contains at least 6 units of vitamin A, okay, 7 units of vitamin B, and 12 units of vitamin C, and 9 units of vitamin D. There are 4 types of vitamin actually. The vitamin contents of 1 kg of uh, 1 kg of food X and 1 kg of food Y are given. Okay, this is given. So 1 kg of food X cost taka how many? 5, and 1 kg of food Y cost taka 8. Cost are given. Formulate the linear programming problem. We have to minimize the cost. Okay. Now decision variable, we have to take the declare the variable uh, decision variables, which is called, and are we let us consider the food X, the units of food X and of food Y. Uh, Let the food X in the mixer be X kg. That means X kg needed. Capital X food will needed how many kg? X kg, and capital Y food will be needed how many kg? Y kg. So objective function we have to confirm 1 kg of X food, 1 kg of X food, taka 5 taka. Okay, so X kg will be how many? 5x taka, and 1 kg food Y will cost how many? 8 taka, and Y kg will be cost, total cost what will be? 8y. So total cost for X and Y will be 5x plus 8y. But this food, this total cost will indicate the objective function. Remember it. Z equals to 5x plus 8y. Now for food X, for vitamin A, we get a constant, and vitamin B, vitamin C, vitamin D. There are 4 constants. Now for the first constants, for vitamin A, the mixer contains at least 6 units vitamin A. Okay, 6 units vitamin C given, and 1 kg of X food contain 1 unit of vitamin A, and X kg will be contain X into 1. Okay, and 1 kg of Y contain 1 unit of vitamin A, so Y kg will contain 2y. Okay, so total vitamin A contain X plus 2y Y, but this is at least. Okay, at least means you can take more than that. So this whole vitamin A available how many? 6 kg, 6 units available. This why this cannot be greater than cannot be less than 6. Okay, and it is also minimization problem. We can take more than 6 vitamin A. So for the second constraints, that means vitamin B, 7 units available in vitamin B. So a 1 kg of X unit contain 1 unit of vitamin B, and X kg will be 1 into X. And 1 kg of Y contains 1 unit vitamin B, and Y kg of food Y contains Y unit of vitamin B. Okay, this is for 1 kg X and 1 kg Y. This is Y, and total unit of B vitamin what? Total 7 units. So X plus Y greater equal to 7. Similarly, for the third column, vitamin C, there are 12 units available in vitamin C. So 1 kg of X contain 1 kg of X contain 1 units, and so X units will be X into 1, and for Y food thrice X. Okay, so total vitamin C will be how many? X plus thrice Y greater equal to 12, because total vitamin C will be 12. Similarly, vitamin D, 9 available, at least 9. So there is at least word. This is why we are using greater equal to. Now 1 kg of food X contain 2 units of vitamin D. So X kg will be twice X. And 1 kg of Y contains 1 unit of vitamin D. So Y kg will contain only 1 into Y. That means Y units. So total vitamin D what? At least twice X plus Y greater equal to 9. At least this is why. Now another constant, which is taking food of capital X and capital Y, can never be negative. That means X greater equal to 0 and Y greater equal to 0. This is called non-negativity restrictions. So mathematical formulation at last in 4 steps. The linear programming problem of the given problem is as follows: to minimize this z objective function, and subject to the constraints. There are 4 constraints, remember it, and this is the non-negativity restrictions. So this whole 1 equation 2 to up to 6, this whole equation is called what? Linear programming problem. Understand, everybody? Now type 3, another form of linear programming problem. Actually this is called transportation problem. Understand? So this transportation problem, actually how to formulate, we will try to understand. There is a factory located at each of the 2 places P and Q. Okay, there are one factory P and other factory what? Q. Okay, there are 2 factory, remember it. So actually at each of the 2 places, from these locations a certain commodity is delivered to each of the 3 depots situated at A, B and C. The depots are, this is A depot and this is B depot and this is the what? C depot. We have to deliver the product, okay, from the factory. Understand? This is the depot. The weekly requirements of the depots are respectively 5, 5 and 4 units of the commodity. Requirements how many? 5, 5 and 4. Remember it. We have plotted the diagram. The weekly requirements of the depots are respectively 5, 5 and 4 units of the commodity, while the production capacity of the factories at P and Q are 8. P and Q are 8 units production capacity. Okay, 8 units means 8 lakh metric ton or 8,000 metric ton or 6,000 metric ton, like this. Okay, so 8 and 6, that means P factory 8 units and Q factory 6 units respectively. So that's sufficient for the requirements of the depots. The cost of transportation per unit are given below. Okay, for P factory, cost A depots cost 16, B depots cost how many? 10 taka, and C depots 15 taka for from P factory, and from Q factory 10 taka of depots A, and 12 taka of depots B, and 10 taka of depots C. How many units should be transported from each factory to each depots in order that the transportation cost is minimum? That means you have to can minimize the transportation cost. This is the very important part of linear programming problem. We are minimizing cost, maximizing the profit. Okay. and formulate the above as linear programming problem. So the given information it can be shown in figure. Okay, this is the factory P and which available 8 units capacity, and factory Q 6 units capacity. There are 3 depots and 5 depots. 5 units in depot A, 5 units in depot B available, and depot C is 4 units. Okay, now decision variable can be taken as from the both factory. Let the factory P transported X units of commodity to depot A and Y units to depot at B. That means X units coming from what? Depots coming from factory A to what? Depots A, and Y units coming what? In depots B. Remember it. So the remaining units will be how many? 8 minus, there are available what? 8 units. So X units going A depots, and Y units giving to B depots. So the remaining how many? 8 minus X minus Y. Okay, 8 minus X minus Y will go where? In third depot. That means in depot C. So now we can formulate the constraints. Factory P, from the factory P, at P, how many? 8 minus X minus Y units will be transported to the depots at C. Okay, 8 minus X plus Y, which will be must be greater or equal to 0, because there will be no negative units. Understand? This is why this will be the transported products units will be must be non-negative. So 8 minus X minus Y greater or equal to 0. So it can be written as X plus Y less equal to 8 after solving. Now this is the equation number 1. Now another constants 2, X and Y units are in non-negative. So X greater or equal to 0 and Y greater or equal to 0. Again, for the constant, third constants, the remaining requirements 5 minus X units are to be transported from the factory Q to the depots A. There are 6 units available. Okay, in factory Q, 6 units. So uh, the remaining requirements, 5 minus X units are to be transported from the factory at Q to the depots A. There are actually 5 units. Okay, so and 5 units available, but X units come from here. Okay, X units come from here. So there will be available how many? 5 minus X. Understand? How many will be available from Q? 5 minus X, because X units coming has come from P factory. Okay, so from Q factory how many will be exist? 5 minus X. So the remaining requirements 5 minus X units are to be transported from Q. Understand? To the depots A. So the constant 4 can be written as this 5 minus X must be non-negative. So X less equal to 5. So the remaining requirements 5 minus Y. That means this is the 5 units requirements, and Y comes from what? P factory. So rest will be what? Rest will be 5 minus Y, and this will be transported from what? Q to the depot B, 5 minus Y, and this 5 minus Y must be non-negative. So Y less equal to 5. So another constants 5, the remaining requirements, that means in C how many units here? 8 minus X minus Y units. Okay, coming from P factory, and remaining means what? 4 minus this whole, 4 minus this whole, 4 minus this whole will come from where? Transported from Q units to the C depot, and this will be must be non-negative. So this can be make a equation 5 5 10, and after solving this we get 4 minus 5 what? 4 minus 5 minus 1. So minus 1 plus 5 4. X plus Y greater equal to 4. Now we can formulate how to formulate the objective function. Actually, the transportation cost from the factory P to the depot A, B, C are given what? 16X, 10Y, and 15 into this. Transportation cost per unit given from P, 16 units, 16 taka per unit of for depot B depot 10 taka, and for C depots how many taka? 15 taka. So there are available how many? The transportation cost from the factory P to the depots A, B, C respectively how many? We have taken for P X. This was 16x, and for B for B will be how many taka? 10 taka. This was 10y. Okay, and the rest are how many from P? 8 minus x plus y, and this will be 15 into 15 means what? Taka of C depot 15 taka per unit. So these units will be cost 15 into this. So total cost transportation from the factory P, this just taking addition. Okay, adding this 3 16x plus 10y plus 15 into this. Similarly, the transportation cost from the factory Q to the depots A, B, C are the 10 into 5 minus x, 10 into 5 minus x. Okay, then for B, transportation cost how many? 12 into 5 minus y, and 10 into x plus minus 4. This calculation. Okay, this calculation 10 into x plus 1. So total cost for the factory Q will be what? Just taking sum these three. So grand total means what? Taking total plus total cost of P and total cost of Q. This will be the grand total cost for the transportation from both the factories at P and Q will be depots. This plus this. Okay. So after taking this sum, we get x minus 7y plus 190 as the total cost. That means we have to minimize this cost. Understand? Minimize this cost for well transportation. Okay, to make a well transportation problem. So this is the objective function, and the mathematical formulation will be the objective function and the constants. Okay, there are 4 constants, and this is the non-negativity restrictions. This is also constants. So and this whole make what? Formulation of LPP problem for the given this transportation problem. Understand everybody? This is factory fee 8 units available, and in factory C Q 6 units available. But there are 3 depots available. What? 5 units in B depots 5 units available, and depot C 4 units available. So if X units coming from factory P, then the rest will be come from factory Q. Rest what will be 5 minus X. 5 minus X will be come from here. And if Y units come from P factory to depot B, then rest of the part of depots B will come from factory Q. That means 5 minus Y. Okay, 5 minus Y. And this cost how many? 16 taka. And this cost for transportation need 10 taka. And this cost how many? Needed 15 taka. Okay, for coming the product from P factory to C depots, and the rest 8 units available here. So X units gone on F depots, and Y units gone on B depots. So rest how many will be? 8 minus X plus minus Y will come to C depots. So there are 5 units available. 5 minus X will be depot units come from Q, and 5 minus Y comes from what? Q factory. So the rest how many? There are 4 available. So 4 minus this will come from factory Q. 4, this 4 minus this units, and this will carry how many taka? Carry cost how many? 15 taka, and this will carry cost 12 taka, and this is the carry how many taka? 10 taka. So now for the first objective function, for the for the cost of factory P, 16 into X plus 10 into Y plus 15 into this. Okay, this is the first total cost for factory P, and 10 into this 5 minus X, and 12 into 5 minus Y plus 15 into 4 minus this. Total will give the cost for the factory Q, transportation cost. And grand total cost how many? Taking sum this whole. Okay, this for factory P this sum, for factory q this sum, will get this the total grand total cost for the transportation problem. And just arranging this objective function, cost will be must be objective function, and this will the constant. There are four constants and one is non-negativity restrictions. So this whole make a linear programming problem for the given transportation problem. There is the application of linear programming problem, real life example. If a young man rides his motorcycle at 25 km per hour, he had to spend taka 2 per kilometer on petrol. Okay. If he rides at faster speed of 40 km per hour, the petrol cost increases at taka 5 per kilometer. He has taka 100, total taka 100 to spend the petrol, and wish to find what the maximum distance he can travel within 1 hour. Express this as a linear programming problem and solve it graphically. Okay, the above information can be taken in the table. Suppose speed per kilometer hour 25 kilometer per hour. Another one is what, 40 kilometer per hour. The consumption of petrol, how many? 2.
2 liter.
Consumption of 2 liter, uh, 2 per kilometer on petrol spend taka. This is the taka. Okay, taka. And for 40 kilometer per hour 5 taka cost. So total amount cost how many? 100 taka. Decision variable you can take. Let us consider the kilometer of riding motorcycle at speed 25 kilometer x kilometer, 25 kilometer per hour for x kilometer, and let the number of kilometer riding motorcycle at the speed 40 kilometer per hour will be y kilometer. So total journey maximize, we have to maximize the journey, total journey. Okay, z equals to what will be x plus y. 25 কিলোমিটার স্পিডে x কিলোমিটার গেছে আর 40 কিলোমিটার স্পিডে কত গেছে y কিলোমিটার গেছে, how many total x plus y. This is the objective function. We have to maximize the distance. Okay, within 100 taka. Now first constraints, first one, the young man has 100 to spend taka. Okay, when the speed was 25, the speed is 25 kilometer per hour, the petrol of cost one for 1 kilometer taka 2. For the 25 kilometer per hour x kilometer cost how many, twice x. And 40 kilometer per hour petrol cost how many, 5 taka. So 40 kilometer per hour y kilometer will be cost how many, 5y. So total cost can be taken as twice x plus 5y less equal to 100, because total taka 100, and this 100 taka cannot be exceed this 100. Okay, so second constraint, we must know time equals to distance by speed. If we divide the distance with the speed, we get time. So time taken in the first journey, x divided by 25. Okay, distance how many, x kilometer, and speed what was first journey 25. And for the time taken in the second journey distance what, y, and kilometer per hour velocity, so y by 40. So total time given how many, 1 hour. In 1 hour he want to travel maximum distance with his motorcycle. So this can be written as x divided by, just taking sum, this is this time plus this time, how many time will be 1 hour. This 1 hour cannot be exceed, so less equal to. So the another constants, and he will journey with 25 kilometer journey x and 25 kilometer per hour journey y, a kilometer can never be negative. Okay, this is the non-negativity restriction. So mathematical formulation maximize the, we are maximizing the total distance x plus y, and subject to the constants what will be. And this cannot exceed 100 taka because he has only 100 taka. And time taken will be 1 hour. This total hour cannot be exceed 1 hour. So these two, this can be written as this. So this is the objective function equation 1, 2 and 3 is the what, constants, and equation 4 is the what, non-negativity restriction. Now try to solve this in graphically. Region represented by the constants. Now making this inequality to equality equation, right? First of all, you have to make inequality to equality equation. Then for the first inequality, we get twice x plus 5y equal to what, 100. So putting y equals to 0, we get x equals to what, 50, and putting x equals to 0, 5y equals to 100, that means y equals to what, 20. So we get 2 points A and B. For another constraints, this 8x plus 5y less equal to 200. So for this second constraints, putting y equals to 0, if y equals to 0, 8x equals to what will be 200. So x equals to 200 divided by 8. 200 divided by 8 means what, 25. So if x equals to 0, then 5y equals to what will be 200. So y equals to what will be 40. So there are another point C and D. Now plotting A B,
Sir,
just A, this A point and this B point, just joining this. Okay, 5 10, just increasing 5, 5 10, increasing 5, we have taken the point. Now another C point will be 25 in X, 25 this, and 40 will be what, this. So joining this C point and D point, we get the second constant. Because this is the less equal to, remember it, this is the less equal to, at least, sorry, less equal to, cannot exceed this. So the direction will be, the shaded region will be higher, directed to origin. Okay, so this is the shaded region. So there are three corner points, one is B, other is E, this is the intersection point, and this is the C. Okay, C point, how E point, how many we can, how we can get, just solving these two, second constant and third constant solving. Okay, but just subtracting, we get 8x minus twice x, what will 6x equals to 100, x equals to what will be 100 by 6, that means 50 by 3. Then putting x equal to value, we get y values. So the corner point, the corner points, the coordinate of the vertices is U C E B U R, U point 00, C point 25 0, and E point what, this, and B point what, 0 20. So the corner points are given in first column, and the value of z, that means objective function, will give, just putting x equals to 25 and y equals to 0 in objective function, we get 25. And this putting x equals to 50 by 3 and y equals to 40 by 3 in objective function, we get only 30. So the maximum is 30 kilometer here. Okay, so this maximum required from where, at this point. Okay, 50 by 3 and 40 by 3 point. So if x equals to 50 by 3 and y equals to 40 by 3, then he can travel, the young man can travel maximum distance 30 kilometer. Understand? If z equals to 30 kilometer is maximum when x equals to 50 by 3 and y equals to 40 by 3. That means in 25 kilometer per hour, if he can travel 50 by 3 kilometer, and in 40 kilometer per hour, in 40 kilometer per hour, if he can travel 40 by 3 meter, then he can travel maximum distance with 1 hour and with the 100 taka petrols.